So my dear students, today we are going to see this non-deterministic finite automata. So let's clear one by one each point. So NFA allows 0, 1 or more transition from one state to another for an input symbol. So we know in DFA what happened, that in DFA from a state for a single input we have only one output state, and in case of NFA what we have from a state for a single input that is A, we have multiple output states, and it is possible in case of NFA only. In case of DFA this is not possible. So let us suppose that we have this state, and this state is named as Q0, and after reading an input symbol that is A, we can move to this state, and at the same time we can move to this state. So this is not possible in case of DFA, but it is possible in case of NFA here. Okay, so again if we'll write like this is possible. Okay, so this is possible in case of NFA and DFA both. So it is not possible that for a single input we can have multiple outputs. Okay, single means A and A, not A and B. Okay, good. So the next point is DFA is a special case of NFA, and definitely we can have a DFA. So for A we are moving, let us suppose this example, let's take this example. From Q0 for A we can move here and we can move here. So if we'll talk about DFA, so we'll have this one. For A we can move to only one place. So DFA is always going to be a special case of NFA. Okay, we'll see more example later about this one. So unique transition. Okay, and for a string W, NFA may have several parts. Definitely for a string W can be a combination of alphabets. So W equal to, if let's suppose W equal to AB, we have two alphabets. So from a state it is clearly visible above also that for A we can move to more than one place. We can move to more than one place. So it is but obvious that we have more than one paths. Okay, and DFA we have a single dedicated path itself for a single input. Remember this one. Okay, so like DFA there is also, we have 5 tuples through which we can define a NFA. So we know about this one. This is a set of states, this is a set of input alphabet, and this is initial state, and this is the set of final states. The only difference is in transition function del. Okay, so we have this one. In case of DFA, what happened? We have this Q, we have this sigma, and it is going to map with where? It is going to map with this Q, and it is a number of state. So 2 to the power Q is the power set. So what is the power set? All the set of all the subsets. Okay, so let's try to figure out. Let us suppose that in an NFA we have two states, that is Q0 and Q1 only. So we have two states in NFA. Okay, so what is 2 to the power Q? So it is the power set of this one. Okay, so we have two alphabets, so 2 to the power Q, and this is what? This is in Q we have only two states. Okay, so we'll see how to make an NFA. Right now we assume that we have two states, that is Q0 and Q1, and we'll have to identify 2 to the power Q. So that is, we have two elements, that is 2 to the power Q, because we have here two elements, and that is how it is going to give you 4. So what are these 4 states are? So this is 5, we have Q0, we have Q1, and we have Q0, Q1. Write this all state in curly braces itself. In curly braces. This is the notation of. So we have this one. So this is how it is going to give you 4 state, and by using this 4 state we are going to map this one. We'll see an example in NFA. We'll try to clear this one also. Okay, so right now we have this one. So this is the mapping and this is the transition which we are going to use in case of NFA. Okay, now let's see. So we'll see the working of this NFA. So we have this finite control here. We have this finite control and it is in a state that is Q0, and we have an input alphabet that is A. Okay, now let's try to understand. So in case of NFA, this is a transition function and this is the brain of this NFA. Okay, and remember one thing, that NFA is not associated with any kind of memory. Okay, so NFA is not having any memory. Okay, so we have this Q0 any state and it is going to read this A, and so what will happen, see, it will move, it will shift to right side, and it is having 2 states. So after reading A, it can move to any state, that is Q1 and Q0. Okay, now again by reading B, it can move to Q2 and Q1. So again it can have 1 state, 2 state, or more than 2 state is possible. And after reading this B, we will move to final state. So by using this one, we know this thing, that by reading a single input in a state, we can move to more than 1 state. So by using this, we can reach to final state. Okay, now we have some properties related to this NFA. So this one we know very well. So it can be seen here directly by using diagram. So this is a Q, and see, after reading A, it is going to move here itself. So this is a self loop. Okay, so it can be in self, it can be goes anywhere. Okay, so it can be moved anywhere else also. So we can have this one is also possible, right? Just give the name of the state also. Okay, Q0, Q1, and give the direction also. Good. So this is possible. We know this one from the DFA. So we'll try to understand this one. So Q is a single state, and we have a string and an alphabet. Okay. So it is written that for some state R in QW. So first of all, we are going to solve this one from here itself. Try to understand this one. Okay. So we are going to consider this one. So W can have any value. We know this one. W can have any value. So it can be any string of A, B, A, whatever you want, you can give. Okay, so what will happen here? So we want to say that after reading this W, so it can have more intermediate state for A, for B, and for A. So collectively known as W. So we will move to some state that is R, and that is what it is written here for some state R. Okay, so by reading this one, we can move to, so this W is comprises of so many states. Okay, like this. So someone is reading A and it will move towards some state, and after taking B, it can move towards somewhere like this one. So this is the intermediate state which will come here itself. Okay, so by reading this, we will reach to finally R, and in R we have a single input. See, we are left with only last one that is last alphabet. Okay, so by reading this one, we can reach to our final state. This will become our final state. That's all. So this is the notation which we are going to use for this final state. Okay, so we have this one. Okay, so let's take this third point. Okay, so we have P. P is what? It can have number of states. So P can have more than 1 state also. So it is also possible Q0, Q1. It can have many states. Q0, Q1, Q2, Q3. Okay. So this P is there. Okay. So it is written, and we know this W. We have seen this one. How to solve this one? Okay. So it is written that Q in P. Okay. So this Q belongs to this P. Okay. So what will happen? So if I want to see, this Q is from P. So P is having this states. So if I'll write this transition function, so Q0 is going to read this W. Q0 is going to read this W because we took this Q from here itself, and union. This is the union. So Q in P. So how many Q we have? Q0 and Q1. So again we'll have to write this transition function here for Q1. Okay, so we have this one. So we can solve this from here itself like this. And this will be again solved. And whatever be the result, you are going to take union of that one. That's all. That is the meaning of this one. So let's try to understand this example. So we have a transition written here. Okay. So Q0, after reading 0, it will move to two states, that is Q0, Q3. Okay. Now again I have written this one, Q0, 0, 1. So Q0, Q01, it means we are implementing here second property. We are going to implement the second property. Okay. So we are going to solve this one first. And see, we have this result, that is Q0 and Q3. It is already written. So del Q00 is going to give you Q0, Q3. So first of all, we are going to solve this one, and that is like this one. Okay, whatever be the, so it is here we have only one value. That's why we have solved for 0 itself. Okay, so after solving this, we are going to get this one. See, this is a number of states. We have more than one state is available. Sorry, we have more than one state is available. So it is clearly visible here. Okay, now what to do? So we'll take this Q0 with this one. We take this Q3 with this one, and we'll take union of this one. So see, we took this one like this one. We took this one like this one, and we took union of this one. That's all. So Q0, Q1 is going to give you something, that is, if let's assume that it is going to give you Q0 and Q31 is going to give you Q1, and you will have to do union, and that's how we are going to perform this property. We'll see later more example related to this one. Okay, now let's move forward. So consider this diagram. So this is a state transition diagram, and we know this is all about NFA. Okay, so you can easily verify from here for this in state Q0 for 0 input, we'll have this Q0 and Q3 itself. Okay, the first one is that one, and it is not required in NFA that for every input we are going to give any kind of, or we'll have to give transition for that one. Okay, so see, in Q3 we didn't have any kind of transition for 1. So this is the second one. Now let's see the normal. So we are going to define this all tuples. So for Q we have the number of states. The input alphabet is 0, 1. It is clearly visible. Initial state is Q0. We are starting from here itself. And Q2, Q4 is the final state. So we know this is final state. Okay, so this is all. And now this is a transition. Okay, for Q0, we'll see after reading this 0, we'll move to Q0 and Q3. And that is how it is written in curly braces. For Q0, we'll have this 1. In Q0, after reading 1, what we have? We have this Q0 and Q1. So we have this one. Okay, similarly, we are going to fill this table. So in Q1, for 0, see, we didn't have any kind of transition. In Q1, for 0, we didn't have any kind of transition, so we are going to do 5. That's all. Okay. So we are going to see this. Let me clear the screen. Okay. Okay. Now we are going to see the proliferation for the string. How this string will be get expanded. Okay. For this input. For this input. Okay, so first of all we'll start from 0. So in Q0 we are going to give 0, and we have two states. See, in Q0 we'll see from this diagram. So from Q0, if we read Q0, we'll have Q0 and Q3. So we have two states, that is Q0 and Q3. Again again I am going to take this 1 as an input, and in Q0 for 1 again we have this Q0 and Q1, and now we are going to consider this Q3 also. This is active. For 1 this is active and this is active right now. So in Q3 for 1 we didn't have kind of any transition, so it will be get closed. That's all. Now we have two active states, that is this. Now in Q0 again I am going to read this 0. For Q0 0 we have again two states, that is Q0 and Q3, and in Q1 we didn't have any kind of transition here, so it is going to be cancelled. Again from Q0 we are going to take this 0 itself, so 0 we have Q0, Q3, and from Q3 by giving 0 we will have this Q4 itself. Yes or no? Now we have three states, Q0, Q3 and Q4, and we are going to take this one, last one. So in Q0 for 1 we have this Q0, Q1. From Q3 for 1 we didn't have kind of any transition, it is going to be cancelled, and we have one this Q4. Now see, we have so many paths available, and that is how it is written in your first slide, that we have multiple paths. But try to understand one thing, after reading all the input string, the path which is moving towards your final state, we are going to consider that path only. So we are going to consider this path itself, this path. Why? Because it reached to the final state after reading all the string. Although these are the paths also available, but they are not able to reach to the final states. That's why these paths are going to be cancelled. We are not going to consider this path itself. Okay, so this is how the NFA works. Okay, so now we will move forward. Now let's an example of NFA. So we have a language that tells us about that it is going to end with A over the input alphabet AB. It is given here. Okay, so now let's try to understand one thing. So we have this example. So it is very easy to make. Let's understand that it is very easy to make NFA. So first of all I have made this A because it is going to end with A, and whatever with the AB we want, we can give it in the starting phase, that is AB. Okay, now let's try to understand one more thing. Okay, so what we have here, we have input alphabet is given already, that is AB, it is given. Okay, now let's try to understand one thing more. What we have for A, let's try to understand this one. So we have A state, and A can read what? A can read what? B. These are the number of states. Okay, so B can also read this one. It can read. In this case, it is not happening right now. Okay, so we have this one. Try to understand. So what is it? This is what? This is your state. This is your input alphabet. Now we'll try to map it. By the power set, that is what? 2 to the power Q, and that is how we are going to get this phi. We have this A, we have this B, and we have this AB. Because why this is happening right now? See, put a curly braces over there. So we have this one. Now see, put it bracket here itself. So it will going to give you the transition. So we have a state and input. We have the state and input itself. Okay, this is a small b. So for A, from this diagram, for A and having A input, where we can go? We can move to this B itself, and we can move to A also. For AB, what will happen? In A, for B, we can move to A itself. And see, for BA we didn't have any kind of mapping there, so we can move to Phi itself. So that is how it is going to be taken. So this is how it is going to be mapped. See, the mapping is there. Okay, so let us suppose if you want to make a DFA for this one, so ends with A. So what will happen? First of all, let's try to understand this one. So if we'll have to make an DFA for that one, the same question, and with A. So we are going to take this A here itself. Yes or no? And with A. So it doesn't matter how many B's we give in starting phase. Okay. So see, if I am going to get that what? Yeah, I am going to get this B here itself. That is how we are going to make the DFA. Okay. So and with A. See. Let's give. Okay. If we have A at the end phase, we are going to get this one. Yes or no? So this is how we are going to deal with this. So from here it is clearly visible that it is very hard to make this DFA as compared to this NFA. See this one. So both are equivalent to each other. So we will see that conversion of DFA from NFA. We'll see that one later. Okay. So right now this is the DFA for this one. Okay. We'll see that conversion also. Okay. Now let's try to understand. So for a single string, so alphabet, if we want to take the transition, we want to see the transition from this state. So for A, we will move here, and for A, we will move here. Okay. This is a simple transition for this one. So by giving this A, we can move to A itself, and we can move to B itself. So we are going to take this path because this is going to give us the final state after ending the string. Okay. So let's consider this diagram for this string AB. So while from A, if we'll give A, again we have two options for this A and this is B. Again we are going to take this B. From this A, we are going to reach this A itself due to self loop. And from B, we didn't have any kind of path, so we will reach to this Phi. So this string will be not going to accept by this diagram, AB. And see, it is not ended with A also. So this must be discarded by this diagram itself. So that is how it is written. If after reading all input string, we reach to final state, means by following any path, then the string is accepted. So in my next video, we are going to see about that conversion of NFA to DFA. So we are going to convert the NFA into corresponding DFA. So hope this concept is clear to you. Thanks a lot.